Hello guys, welcome to Pepcoding, and now I'm going to start with the next question. Construct a BST from level order traversal. So in this question, we have been given one level order traversal, and with the help of this array, we are going to construct the BST. Okay, so this is our question. So we are going to construct the BST from the level order traversal. So let's go and discuss this question. So okay, so in this we have been given this level order array, and then what we have to do, we have to construct this tree, okay, using this array. Okay, now I hope your question is clear. So how can we do this? So before telling you the approach, I would like to tell you about what is level order. I know you already know this, what is level order, but I'm going to tell you what is level order traversal. Level order traversal is something like this. Traversal horizontally. First it will come 50, then 17, 72, then 12, 23, 54, 76, then 9, 14, 19, 67. So this is actually the level order traversal. Okay. So now let's go and discuss the approach. So how we are going to do this? So for this, I'm going to take one queue. Okay, I'm going to create one queue. So this whole space is our queue. Okay, and in queue, what I'm going to push is I'm going to push the one pair class. Okay, one pair. It can be anything. I can let me take level pair. Okay, so in question also it is given it. Okay, so we are going to push the object of level pair. Okay, so what is stored, what we will store in this level pair? So first I'm going to store the parent. Okay, so first I'm going to store the parent. Then what I'm going to store, I'm going to store the lower bound and right bound. Okay, what is lower bound, right bound? So you have already seen my last videos, so you already know about this, what is lower bound and what is right bound. It is not lower bound, it is left bound, and it is right bound. Okay, so we have to create the BST, so we need to specify these ranges. Okay, so we have to work with these ranges, so that's why we are storing the one object in which we are going to store one parent and the two things also. First is lower bound and the second not lower bound, left bound, and the second one is right bound. Okay, so for this, what is the range for this? So we already know the range for this is minus infinity to 50 or 50 to infinity. Okay, so this side we are going to store the node for this range, and to the right side we are going to store the node of this range. Okay, so that's why we are going to deal with these left bound and right bound ranges. Okay, so we have discussed what we are going to store there. So before like moving forward, I would like to specify the ranges of each node. Okay, so what will be the range for this? So the range for this is minus infinity to 17. Okay, so the all the element to the left will be the smaller than 17 and greater than minus infinity. Okay, and what is the range for right side? Right side will be 17 to 50. Okay, so this is left bound and this is right bound. Left bound, right bound, and this is left bound, right bound. This is also left bound, right bound. Okay, so what is the range for this? The range for this is minus infinity to 12. Okay, minus infinity to 12, because in the range for this is they can be smaller than they can be smaller than 12 and greater than minus infinity. Okay, so what will be the range for this side? So it will be greater than 12 and less than 17, because we have already specified there, like they will be less than 17. Okay, so the range will be 12 to 17. Okay, so like this we are going to specify the all the ranges. So what I'm going to do is I'm going to store the pair. Okay, so like there are no nodes, so by default what we are going to store, we are going to store the 0, not 0. Parent will be null. Okay, so parent will be null. And what is the value of LB? LB will be minus infinity to infinity. Okay, so in the starting we are going to store null and minus infinity to infinity in the queue. Okay, so we have inserted one element in the queue. Then what I'm going to do is I'm going to take one IDX variable. I'm going to take one IDX. Okay, so I'm going to iterate this IDX one by one in this array, and I'm going to like fit this node into the correct position in the binary in the BST tree. Okay, so this is our BST. So here I'm going to create the our BST. So I'm going to fit one by one. I would like to fit the correct position of this element, each and every element. So right now there is no element, so this will be our root element. Okay, so let me discuss the process how we are going to do. Okay, so first IDX will point to the 0th element. So first IDX will point to the 0th element. So what I'm going to do in this is I'm going to pop the element first. So first I'm going to take a pair variable, and I'm going to store this value and pop it. Okay, so I'm going to pop this, or you can say remove this from the queue, and I'm going to store this in pair class. Okay, so this is actually our parent. So it is null, so null is not a parent. Okay, so then after that what I'm going to do, the second step is I'm going to check this whether this element lie in this range or not. Okay, so let me write all the steps here so that it is easy to code us. The first step is I'm going to pop, you can say remove the element in queue and store it in pair variable. Okay, first step is this. The second step is to check the node, check array of IDX, that we are going to check the element in the range, okay, if not then we are going to continue. So first there is null, so if the parent is null, then what we are going to do, if the pair of parent is null, then we are going to create the root node. So this node will be the root node. Okay, so this is what we are going to do. So first I'm going to see that whether this is a root node or not. So if this is a pair class, this is actually pair variable, so I'm going to read the pair of parent. Okay, this is parent variable, then this is left bound and this is right bound. Okay, if the pair of parent is null, then I'm going to create this as a root node. Okay, and this lies in this range because this is minus infinity to infinity. So this is our root node. Okay, then I will increment the IDX. Okay, then I forgot one step. Like before incrementing the IDX, what I'm going to do is I'm going to store the two things, that is this range and this range. Okay, not I'm going to store for 50. Okay, so first what we have to do, we have to store this range as well as this range. Okay, so we have to push the object in the queue. Okay, and in which we have to set the lower bound and right bound, not lower bound, left bound and right bound. And then again in the second object we are going to set this left bound value and the right bound value. So what I'm going to do, I'm going to push the two object, and what will be the parent? Now the parent is this 50. Okay, so 50, I'm going to push it like this. Now what will be the lower bound? Lower bound will actually equal to the minus infinity, and the right bound will be the node dot val. Okay, so this is actually a node of val, that is equal to the 50. Okay, then here it is node dot val or up to infinity. So this is what we are going to store in Q. Okay, now let's move to the next iteration, that is IDX will increase. Now what we will do, we are going to check whether this node will insert in this or not. Okay, for this what I'm going to do, I'm going to pop this, and now pair will be pointing this. Okay, now the pair will be pointing this element. Now this is the pair. Okay, so does this array of IDX uh, is in the range of this minus infinity to 50? Yes. So if this element array of IDX is come under in this range, from left bound to right bound, between left bound to right bound, then what I will do, I'm going to create a node. Okay, so I'm going to create the node, and then I have to insert this node. Okay, now you might be thinking like, where I will insert this node, to the left of this parent node or to the right of this parent node. You might be thinking like, where it is a genuine question actually, where we will insert this node, to the left side or the right side. Okay, so let me write some steps. So I have written the second step, that is I will check whether array of IDX is in the range or not. So if yes, if this condition is false, then what I'm going to do, if this condition is false, then I'm going to continue it. Okay, so I'm going to again repeat the same step, that I like to pop the element from the queue and check for the another element. Okay, suppose this condition is true, then what I'm going to do, then I'm going to create a node. Okay, the third step is to create a node, create a node of array of IDX. Okay, the value will be the array of IDX. So again what I have done is I have created the node. Now I have to set it. Okay, so now I have to set it. Now where we will where this node will go. Okay, so what will be the condition for this? Let me specify this. What will be the condition for this, like whether we the 17, we have already seen like 17 is in the range, but we don't know whether where it will come. It will come to the left side or to the right side. Okay, so if this node of val is less than parent dot null, pair dot parent. Okay, if this value is smaller, then we are going to attach to the left side. If this value is greater, then we are going to attach to the right side. Okay, let me repeat again. If this node value is smaller than this value, okay, if this value is smaller, then what we are going to do, we are going to attach to the left side. If this value is greater, then we are going to attach to the right side. Okay, let me repeat once again. If this value is smaller, then we are going to attach to the left side. If this value is greater than this value, then we are going to attach to the right side. If this value is smaller to the parent node, then we are going to attach to the left or right, because we already know, like in BST, all the values are all the smaller values are to the right side, to the left side, and all the greater value are to the right side. Okay, so this value is smaller than the parent node. Okay, so parent node of value, this is actually the smaller, because 50 is greater and 17 is smaller. Then where we are going to attach, we are going to attach here. And then what is the next step? We have to set the range for this, like this value, this range. Okay, so let's do this. Let's set the range 17, 17. This is our parent node. Now this will be our parent node and there will be some more child. Okay, so what is the value of left bound? Left bound is actually equal to the left bound, that is minus infinity. And what is the right bound? Right bound is equal to the node of val, that is 17. And in case of right, so left bound is equal to the node of val, that is 17. And what is the value of right bound? Right bound is actually equal to the right bound only. Okay, that is 50. Okay, so we have also set this value, these two ranges. Now again, we will repeat the same step, that is we are going to pop the element and we are going to store in a pair. Okay, now again we are going to check for the next idx. Now the next value will come, next idx will come. Now it is going to check for this range. So does this 72 lie between this range? Okay, whether this 72 lie in between this range? Yes, it lies. So what we will do, we will just create a node. We'll create a node. And now I'm going to check it whether it will come to the left side or to the right side. Okay, now I'm going to check to the left side or right side. So what is our parent node? Parent node actually is 50, because we are going to we are going to attach this value, this node, to this parent. Okay, that's why we are checking for this. So does 72 is greater than or less than 52? It is greater than, so it will attach to the right side. 72 is going to attach to the right side. Then what we have to do next step? Next step is to set the range 72, 72. Okay, for a left bound, the range will be equal to the left bound only, left bound 50 to infinity. And what is the value from this? For this value, this value is actually equal to the, so let me write, so it will equal to the not 50. So these value are always greater than node dot val. Okay, so what is the range for this? So the range will be 72 and infinity. Okay, so the range for this is 72 infinity, and for this side 50 to 72. Okay, these are the ranges for this. So this range we are going to store it here. So 50 to node dot val, that is 72. And what is the range for this? The range for this is 50 to infinity, not 50, 72 to infinity, 72 to infinity. Okay, so we have also stored the range for this. Now I'm going to see the next one, that is I have set this. Now I will increment the idx value. Now the idx will become this one, 12. So first what will happen? So first we will check whether it lie in the range or not. So first I'm going to pop this and store it. So does 12 lie in this range? Yes, this lies. So what I will do, I will create the node. I'll create the node. Then I have to check for the parent, from the parent, whether this value lie to the left side or the right side. So this is our parent. Okay, because this 17 is our parent. So this value is smaller, so we have to lie left side. Again we are going to set the ranges 12, 12. Okay, left bound will actually become in minus infinity to dot val, and then I'm going to check for change for this value 12 to 17. Okay, so again now I'm going to do little bit quick. Then again we have stored this, then again I am going to erase this. Then I'm going to check for the next one, that is 23. So first I will check for this one. I'm going to pop this, and now I'm going to check for this range. So does this lie? Yes, this lies, 23. And now where we have to attach, we have to check with from the this parent node. The 17 is smaller. Yes, smaller. We have to attach with right side. Then again we have to do the same step. Okay, so we have to just repeat the steps. So let's go and code this. So we are going to code this in Java. Okay, so let me do the full screen. So first what we have to do, we have to create one class. Okay, public static class, and let me take one name, level what I have given in the example, level pair. Okay, so let me take it with the same name, level pair. So this is our class, and we have to create the three variables, that is node, pre-node, and the name is pair. And let me initialize with, let me take this null, and the second variable is int left bound. Let me initialize with minus infinity. Okay, one. Let me take one more variable, that is right bound. Okay, and let me initialize with plus infinity, and let me take the two constructor. Let me create the constructor also. So level pair, first is blank, actually first it will give these default values, and the second one is which will take the t argument. So tree node, first it will receive the pair and the left bound and the right bound. Okay, so let me give the initialize this dot lb to lb, and let me give this also rb equal to rb. Okay, so I've created a constructor also. Now we have to code this. Okay, so what will be our first step? The first step will be our, that we have to create one idx and we have to iterate it, and there is also one queue also. Okay, so let me initialize these two things, idx equal to start with 0, and let me create one queue of type level pair, and let me give the name of the queue is queue, and new, how to create the queue, array dq. Okay, so this is how we create our queue. So we have created the queue, and what we have to do, we have to push that the default thing, see here. So we have to push this. Okay, so we have to add this in queue. So queue dot add, and what I'm going to add, I'm going to add the default values for the level pair. Okay, because in the starting it was null and minus infinity and infinity. Okay, so we have done this also. So now we are having this. Now we have to create one more variable, that is tree node root. Okay, so we have to create the root node also, because in the end what I have to do is I have to return the root node only. Okay, so initialize with null. Okay, now what we will do is we are going to iterate this. What I'm going to iterate, I'm going to iterate this as well as this. Okay, so we will be using the while loop for this. So let me take the while loop, and what is the condition for this while loop? If idx is less than array of, let me take array instead of level order. Okay, array of length. If this is less than the length, or we can also say and if q dot size is not equal to 0, or you can say q dot size is greater than. Okay, so these are the two conditions up to when we have to iterate. Now what we will do is, okay, so first step was, let me see it from here. So we have discussed, the first step was that we have to remove the element from the queue. Sorry, so this was our first step. So first what we have to do, we have to remove the element and store this in pair. So let me do the same thing. So level pair. What I'm going to do, I'm going to remove it. So I have removed the element from the queue and I have stored this in pair variable. Okay, so now the third step is check array of index is in the range or not. Okay, so what we have to check, we have to check that array of index is in this removed range or not. Okay, if it is not, then what we have to, we just have to continue it. Okay, we have to explore some other ways. So we have to check if array of idx is in the range or not. So how we check in the range? We have already discussed in the last few questions. So the range was, suppose this is the left bound and suppose this is the right bound. Okay, if array of index lies somewhere left to the left bound, or you can say right to the right bound, that means that is out of range. Okay, this is out of range. So if node dot data is left to the left bound, you can say if array of idx is left side, that means smaller than the left bound, or you can say greater than the right bound, that means it is out of the range. Okay, so if array of index is less than which thing, pair of left bound. Okay, so if this is smaller than this value, then it is out of the range, or array of idx is greater than pair of left right bound. Okay, if it is greater than this, then it is out of the range. Then what we have to do in this situation, we have to continue. Okay, in this condition we have to continue. Then what is the next step? If suppose this is eligible in this round, in this range, then what we have to do, we just have to create the node and we have to fit in the correct position. So for this we have to create the node. Okay, pre-node, node, new, pre-node, and what is the value of this? The value will be array of idx, and I'm going to increment the idx by 1. Okay, so I'm going to increment the idx by 1. So what I have done is I have created a node. Then I have to fix the position of the node. And what are the possible positions? The root node, it can be root node, or the left side node, or the right side node. Okay, we can fix this in left side, right side, or to the root. Okay, so how can we check for the root node? So we already know if pair of parent is null, that means we are not having any root node. So in that case the root node is equal to that. So if pair of parent is equal to the null, then root is equal to node. Okay, so this we already know. Now let's check for left and right. Now we have to check for left. So what is the condition for the left? If this node, if the value of the node is less than the pair of parent value. Okay, so let me write it first. So if node dot val, if this value is smaller than, if this is smaller than the pair of parent of value, if this value is smaller than the parent value, then that case we have to attach it in left side, else right side. Okay, so let's attach this. So for attach, what I will do? I will do the pair of parent of left. Okay, so in you can see it here from here. Like in tree node, there is value left and right. So we are attaching to the parent of left. Okay, let me attach to the right side also. Okay, so we have also attached to the right side if it is greater than the parent value. Okay, now there is only the last step remaining. Okay, so what is the last step? Last step is we also have to add the two pair object in the queue, because we have to specify the range of that particular thing. See, so we have to specify the range. So we have to specify these ranges. Okay, so we have to specify. So we already know how to find these ranges, how to change these ranges. So as you can see, if you are attaching to this parent node, so what will be the value of lower bound? The lower bound will remain same and right bound will be changing with node.data. So what is the value of lower bound? Lower bound will equal to lower bound only, and right bound will become to the node of value. Okay, so let me add the first object first. QUE dot add. Okay, so I'm going to attach this object of pair class, level pair. So new level pair, and what we have to pass? We have to pass the parent, that is node is our parent, and left bound and right bound. So I will change the value of these. So what is the value of left bound? Left bound is equal to the left bound only. Right bound is equal to the node of val. Okay, so let me also specify the right range, that is this value. So in this, the left bound will become node.data and right bound will become only the right bound only. Okay, so we are going to specify these two ranges. See, these two ranges. Okay, so now the first one will become node.val, and the second one will become right bound only. Okay, right bound. Now what we have to do? We have to return the tree, and our tree is constructed. So let me run this and check for the compile time errors. So there is compile time error. So we have missed 148 line. So let me check it there. So I missed the sample. So let me run it again. And again there is a compile time error. So the error is in 34, 62. There are 4 errors. So 62 and 34. So error is in this line. So I have used So I have directly used the LB because actually I have directly used the LB, but what we have to do? We have to use the pair of LB. Okay, so it will be of pair dot LB and pair dot right. Okay, let me check for all more compile time errors. So it is coming in Q line. So I think everything is correct. So let me check for the okay. So we have not added the import function also. So we have to import java.util.star. Okay. Now let me run this and check for more compile time errors. So now it is accepted. So let me submit for all the test cases. So let me check for all the test cases. So all the test cases are running fine. So thank you guys for watching this video, and we'll meet you in the next video.